More on doing transformations with matrices. Today we're going to learn to find the matrix for a transformation. So the transformation will be given, you'll be asked to find the matrix. Something like we want to reflect in the x-axis. What is the matrix that we use to do this transformation? Right, so last time we were given the transformation matrix, right? It would ask, using this transformation matrix, how does this triangle change? And we actually drew it as well. Here it is. Remember, this was the given triangle with its vectors. The vectors are here inside a matrix. Apply this transformation matrix. We put it in front and multiplied. And what is the resulting triangle? The resulting three vectors that describe the triangle. Then plot it and then describe what happened. So we had to go through all of this and then notice, hey, this is like, it was flipped. It was mirrored in the y-axis, or reflected as we call it. So now we won't be given this transformation matrix. We'll be asked, what does a transformation matrix look like if we want to reflect in the x-axis, reflect in a certain line, do an enlargement? So in order to be able to do this, the identity matrix that we looked at before comes in very handy. Remember, it was in Unit 4. We learned about the identity matrix. Any given matrix multiplied by the identity matrix gives back the original matrix. And it seemed like a useless fact back then, but now it's going to help us out. So remember this. I've copied it down here, except this was like an example, right, with real numbers. Here I've replaced the numbers by letters so that it will work for our formulas. Let's just go through the logic of this one again. We have a matrix, we multiply it by the identity matrix, and it's going to give us the original matrix, right? But let's check that for ourselves again, just once more. This is a 2 by 2, this is a 2 by 2, so we're going to have 2 rows and 2 columns in our answer, right? So 4 numbers. We're going to get this column, we're going to multiply first row by first column, and then second row by first column, right? To get these first 2 numbers. A times 1 is A, B times 0 is nothing. So it's just going to be A, right? 1A and 0B. To get this number, we multiply the second row by the first column. C times 1 is C. D times 0 is 0. So all we have is 1C. So C. Right? I've made them orange because I want you to see that that these are a result of multiplying both rows by this column. So these are a result of only this column and this entire matrix, but not this column, right? We didn't use these blue numbers to get these, right? Because we use the blue numbers to get these 2 numbers. Remember? Second row, no. Second column, first row, second column, I should say. Remember the order. To get this number, first row, second column, I do A times 0 is 0, B times 1 is B. So I write B. To get this one, I take second row, second column, C times 0 is 0, D times 1 is D. And this isn't new because we already know we just multiply by the identity matrix. So sure, we're going to get A, B, C, D just like we had it before. I just want you to see that these two numbers came from multiplying this matrix by this first column, and these numbers came from multiplying this entire matrix by the second column. Okay, now if we right. Okay. So, yes, because I just pointed out that this is a result of the first column only, we could say that if we had our original A, B, C, D matrix and we multiplied by only this first column, 1, 0, our result would be only this column, right? A, C. Do I need to prove it? A, B, there's 1, 0, 1A, 0B. So A, then we do this one, C times 1 is C, D times 0 is nothing, voila, there we go. And in the same way, if we had our original matrix multiplied it by only the second column, our answer would be only the second column. All right, let me get my blue. Voila. And our result would be B and D. Okay. Now I want to take this a step further and look at these two columns as vectors. Remember how last time the columns would be vectors? Top value would be the x value, the bottom one the y value. So let's look at these two columns as vectors. Yeah? What I have down here, I've copied onto my graphing paper. See? AC, and this one down here is over here. Okay. Like I said, I want you to now start to see these two columns as vectors. Yes. This is a matrix, right? We multiply it by this vector, or actually we're multiplying this vector by this matrix. That sounds more logical. And the resulting vector is AC. Let's plot our original vector first. This is 1, 0. So x is 1 and y is 0 in this point, right? Let's plot our other vectors. Well, the blue one, 0, 1, 0, 1 would be here. Just draw a little arrow up there. I decided to color in the little square that it sort of forms together, these two vectors. Now, we have these two vectors. What we want to do with this shape is to reflect it in the y-axis. Okay, and because we have this graph, we can imagine what it's going to look like, right? Reflecting in the y-axis is doing this, flipping it over the y-axis. And I can draw what that would look like it would be a little square, but it would be on this side, right? Now just watch where our orange point has moved to. It's gone from here to there, right? Our new orange point, by applying the transformation matrix, our new orange point has become AC, but it's become -1, 0. So AC are -1, 0. I can put those in here, -1, 0. Those are our values for A and for C. What happened to our blue point, this vector, 0, 1? When we reflected it in the y-axis, because it was on the y-axis, nothing changed, right? So the vector, the blue vector, we applied the transformation matrix to it, and the resulting vector is still 0, 1, right? There it is, 0, 1, 0, 1. So B is 0, D is 1. So the transformation matrix for a reflection in the y-axis is this. So when you apply this to vectors, the shape could be anything here. When you apply this to it, that will reflect the shape you started with, will reflect it in the y-axis. Okay, let's just do another example. We want to find out what is the transformation matrix to do a rotation of 180 degrees clockwise or counterclockwise. It's the same because it's 180. About the point 0, 0. So the center of the rotation is the origin. Okay, let's recognize our vectors first. We have our first vector, 1, 0, right there. And we have our second vector, 0, 1, right there. There. Little arrow. And the square that it sort of shapes together. When we rotate this 180 degrees, this orange point ends up here, right? Orange point ends up there. Rotate this point 180 degrees around the origin, and it ends up here. The resulting square would be right here, right? So we just did a rotation of 180 degrees about the origin. Now, our transformation matrix that we're looking for, when applied to this orange vector, changed this vector to this vector, here called AC. Here we see that the vector is -1, 0, right? -1 is its x value, 0 is its y value. So let's write A and C, because we just found A and C. A was -1, C was the y value here, which is 0. Same for our blue vector. This is our blue original vector. We applied the transformation matrix to it, and it gave us a new vector of 0, -1, 0, -1, 0, -1. So this transformation matrix changes a vector by rotating it 180 degrees about the origin. So even if we had a triangle here or a circle, applying this transformation matrix to it rotates it 180 degrees. Awesome. Let's do one last one. Once again, this is our orange vector, 1, 0. This is our blue vector, 0, 1. We're going to enlarge it by a scale of 3, scale factor of 3, from the origin. So instead of 1 up, it goes 1, 2, 3 up. And here it goes 1, 1, 2, 3 over. So our orange vector will be there. Our blue vector is going to be there. And the resulting little square now became a big square. Let's do this. Okay, this is our resulting shape and the two resulting vectors. So what happened here? We applied the transformation matrix to the vector 1, 0, to this one, and it gave us the results of this point. The resulting vector was this. This point is 3, 0, 3, 0, 3, 0. Yes. What happened to our blue point? Our blue point 0, 1, 0, 1. When it was multiplied by the transformation matrix, it gave us a result of this vector, which is 0, 3, 0, 3, 0, 3. So this transformation matrix will transform any set of vectors by enlarging it with a scale factor of 3 with a center where the center is the origin. Okay, have fun with it.